Okay, so we need to start off this first one here. It says we need to find the equation of this graph right here. Using this equation right here, this y equals a times b to the x. And we've done a lot of these ones in class, so this one shouldn't be too crazy. We're given 2 points though, so we are going to have to kind of flip forms. We can't get it directly from the graph. We can't get the equation right away, because remember, a is going to be wherever we're at, going to cross the y-axis, and b is going to be our multiplier. We're too far away to find our multiplier right now. So what I'm going to do is I'm going to make a table, just an xy table, and I'm going to use the numbers that were given over here. So x, I've got a -1, y, I've got -2. I don't know anything else for 0, 1, 2, 3, but I do know 4. So 0, 1, 2, 3, and 4. And then 4 goes with -64, so I need to put that all the way down here. Alright, so I have to somehow get this value, because this right here is going to be my A, and I have to figure out what I'm jumping by, because that's going to be the B value. So since I don't know, so we did one like this in class where we decided, hey, instead of just guessing and checking, which we also have done, I'm going to say this is going to be -2 times some number x. So this is -2x times x, which is x squared, -2x cubed, -2x to the fourth, and finally -2x to the fifth is going to be this -64. So we want to set these two things equal to each other, and we can solve for x. So I've got -64 equals -2x to the fifth. I have to divide before I can do anything with that exponent right there. So I get 32 equals x to the fifth. Then I can take the fifth root in a calculator, or if I know the fifth root of 32 offhand, I know that that's 2. So I know that my multiplier, I know I'm multiplying by 2 every time. So again, one way to do it is algebraically like this, but we have done guess and check before also. So I know that b equals 2. So now I just need to find a. Well, if I'm starting at -2 here, -2 times 2 is going to end up being -4. So I end up getting y equals -4, 2 to the x. And that's the full equation. Number 2 down here deals a little bit with compound interest. So we talked about compound interest versus simple interest. Compound interest basically just uses the exact same form that's up here. Dawn's parents started a savings account when she started high school. She's got 1966 when she graduates after 4 years. So we do know the point for 1966. We have the account earned 7% per year in compound interest. How much did her parents deposit when she started high school? So the 7%, we can find out our B is going to be 1 plus the percent. And we've done a lot of these ones for homework especially. We've also looked at them in class. So that's going to be B equals 1 plus 0.07. So we get a B value of 1.07. So we know the multiplier, and then all we have to do is kind of step back. So I put that one way up high. I actually like to make the table, so I'm going to make the table over here. 4 goes with 1966. And we need to find out at the very beginning. So this is after 4, after 3, after 2, after 1, and then that's at the very beginning. So what I have to do is, instead of multiplying, because whenever we go down the table we multiply by the multiplier, I have to do the opposite. I have to divide. So I'm going to take 1960 and divide by 1.07, because I'm going backwards. So I'm going to divide by 1.07, and I get 1832 divided by 1.07, so we get to 1712. Then I'm going to divide 1712 by 1.07, and I'll get up to 1600. I'll divide that by 1.07. and we get to $14.95. So that's how much we actually ended up starting at, is that $14.95 number. Now that's due to rounding. I rounded these all to the nearest dollar. If you rounded to the nearest cents, you'd be somewhere in the same realm, somewhere around this 1500 mark. But that's how much that she would actually have put into her account at the very beginning, or her parents put into her account at the very beginning. So we can just kind of circle this one. That's our A value, and we're all set. Number 3, that's another one with one of these percentages. So here, though, we're decreasing at a rate of 5% per year. And then in September 1994, the amount of people was 4,000. Answer the questions and continue. Now, everyone did really well with this one by just saying, hey, 1994 is the same as our start, so they made that the start value. So that's good, because we know that 0 goes with this 4,000. So we made that the initial value. And then here we have our multiplier again. Same deal as up here. We're going to do the multiplier B equals 1 plus the percent. So here it's going to be 1 plus negative 0.05, because we're going down by 5%. So my B value is actually 0.95. And that makes sense, because we're going to multiply by a number smaller than 1, so we're going to keep going down, which matches up with decreasing right here. So our final equation, we get y equals 4,000 times this 0.95 to the x. And so that's what our equation is. Now, if we wanted to, since we do have the n and the t of n, again, that was kind of optional here. I could have also wrote t of n equals 4,000 0.95 to the n. Now, the reason we could have done this, and as long as you answered this part as to why we wanted an n instead of a x officially, is because they wanted to use only whole numbers for years. But again, years are something that you could, if you wanted to, like get a part of a year. You could do it every 6 months and have a half of a year. So you could have chosen n, or you could have chosen x. But that's why they chose n, is because they're measuring it every year. So n is just every year. And if you argued that, you could do it in every half year, that's totally fine. So then we needed to find out how much there would be in September 2010. So what we're going to do is go to 2010. So from 1994 to 2010, that's going to be 16 years. So we're going to make n equals 16. And we're going to plug that into our equation over here. So we're going to end up putting 4,000 times 0.95 to the 16th. So I got to go ahead and type that in. And remember your parentheses with this one, otherwise things are going to get a little bit off. Also remember, we're taking it to the 16th power. We're not multiplying it by 16. It's because that would also give you kind of a really strange result. 0.95 to the 16th. And so we end up at 1760, or 1761 if you're going to round up. Now the important thing here is to round this to a whole number, because you can't have a part of a person. So it's kind of important to either pick 1760 or 1761. Alright, on the back we're going to start off by doing a little bit of graphing. So we're going to have to graph a whole bunch of points onto our coordinate grid right there. So I've plotted all my points. Kind of boring to watch me plot points. But one of the important things is I did make my scale the same on the x-axis and the y-axis. This down here is minutes, by the way. And over here is my temperature. So we kind of can see we have this kind of curve. So it kind of looks like it's going to be exponential. It looks like the coffee temperature is going to keep falling. So I'm going to say that looks exponential because it looks like we have a nice curve. It looks like it's going to be, we're just kind of going down by the same percentage every time. So I'm going to go with that as exponential. So I'm going to say yes. And I'm going to say that curve just kind of tells me that it's going to happen. So then we have to ask, is this continuous or discrete? Again, this is one that you could have answered either way. You could have said continuous because the coffee is still in the cup and it would just still be in the cup even between the time of 0 and 5 minutes. You could say it's discrete because you only have the data points that are every 5 minutes. You don't actually know what these numbers are. So you couldn't actually make a continuous graph. You could make a line of best fit, but not a continuous graph. So either or actually will work out because both work out in reality. Since I left mine as dots, I'm going to say that this is going to be discrete, only because I don't know what's happening between. I don't have any data there, so I'm not going to plot any points because I don't know if my numbers would actually be true or not. Would this ever cross the x-axis in real life? Again, this was a question that was pretty open-ended. Some people said yes, because eventually the coffee is going to cool down to go below 0 if it's freezing outside. Okay, that's true. That's the coffee would freeze and then it would get below 0 degrees Celsius. Some people said no because it would only get to room temperature. Some people said no because it's going to make an asymptote. We don't know where it's going to make an asymptote, but it'll make an asymptote somewhere above 0. Some people have said it would make an asymptote below 0. There's not enough given information up here to give this a definite answer, but I'm going to say no. I'm going to pretend that it's going to be an asymptote at room temperature, that the coffee is just going to level off at room temperature, and that she kept the coffee inside, and so that's why I'm going to pick that one. Then we get the last question, question 5, write an exponential equation for the data in the table. And this is pretty similar to number 1, where we just kind of need to find out our b and then get our a after that. So again, this is going to be 9x, 9x squared, 9x cubed, and then 9x to the 4th. Alright, so I'm going to set those two things equal to each other. 45.5625 equals 9x to the 4th. Divide first. And again, you didn't have to do this one algebraically if you didn't want to do it algebraically. We did do a lot of guess and check stuff, so if you wanted to guess and check, that would be another fine way to do this one. 5625. So I get 5.0625. Equals x to the 4th. And so now we take the 4th root of both of these. Or, at this point, if you wanted to guess at this point, you could guess at this point. You could tell that it's got to be below 2, because 2 to the 4th would be 16, which we've looked at kind of the powers of 2 in class. So this one actually ends up being 1.5. So we know that that's x, and we know then that that's b. So my multiplier is 1.5. So now I need to get all the way back to 0. Well, I can kind of continue to fill out the table, because remember now, instead of multiplying, I'm going to divide by 1.5. So I get from 9 to 6, and then I get from 6 to 4. So I've got my a value of 4, so my equation is y equals 4 times my multiplier of 1.5 to the x.